Feed the Future Innovation Lab for Small Scale Irrigation, otherwise known as the ILSSI project, has been responding to the major challenges relating to agriculture, nutrition, and health across Africa for the last 3 years. Through research and leveraging agricultural innovations, the project is uplifting the lives of smallholder farmers across Ghana, Tanzania, and Ethiopia, and also demonstrating potential for scaling up from individual farms to a national level and even further afield across the African continent. In Ethiopia, the work of the lab uses a combination of research, training, and innovative technology for use in the field to improve food production, enhance nutrition, and transform the economic standing of small-scale farming households across the country. Adequate and sustainable water delivery is the core component that will ultimately allow the Ethiopian farmer to grow and prosper. Water delivery and distribution systems in Ethiopia are now being analysed in collaboration with national university partners in the region. The goal is to prepare students in the long term to undertake the research models themselves and build further capacity and expertise for farmers in the field. One of these research models is the ILSSI.
ILSSI is an abbreviation for Integrated Decision Support System. It's basically a model of measuring the impact of intervention. So basically there are 3 components. The first one, which I concentrate on, is pharmacy. Pharmacy is an economic model, so it collects information across the household and the community on income, nutrition, and other economic variables. The second model is SWOT. It's a soil and water analysis tool. It uses information on topography, altitude, and other things. And APEX basically concentrates on climate and weather data. So all these models together can measure whether an intervention brings an impact on the lives of individuals, taking into account all the natural and social variables.
Before this project, we used to work with traditional farming methods, but now through this project, we have been taught new ways of working. It's a bit different from what we knew before, and now we've learned how to plow in one direction. And I learned that the reason for this is to prevent soil erosion. In general, myself and my family benefited a lot from this project. One of the benefits is also that our children can also learn new skills in their spare time while on the farm. We also showed these new methods to all other farmers that come to our house, and now a lot of them are interested in working the same way because they see it saves water, produces better yields, and provides long-term crop production.
African economies employ almost 65% of the labour force in agriculture, and the sector constitutes over 32% of annual GDP across the continent. In Ethiopia, where 77% of the workforce is employed in agriculture, smallholder farmers must increasingly rely on irrigation to counter the impact of drought and other environmental challenges that threaten their daily livelihoods. The water lifting and delivery systems used in the field and supported by the ILSSI project range from manual water lifting such as rope, pulley, and tanker-based implements to motorized diesel pumps, and now an instrument that can be directly sourced from one of Africa's most ubiquitous resources, the sun. Solar power pumps provide cost-effective power sourcing and a reliable method for farmers in remote areas.
The solar panel has proved very useful. Before, we used to pull out water manually and put it in the tanker. Now with the new solar pump, the water goes straight into the tanker and I'm able to water the vegetables. This new method has saved me quite a lot of time, energy and money, and I would recommend this type of working technique to all other farmers. To make the best use of this system, I learned that it is important to save and conserve water. And we now store all the water from the winter season in tankers. This new method has also allowed us to increase our yields. We are now able to produce maize up to 3 times a year, so I would definitely suggest that solar technology be made more widely available.
The majority of the components for the SSI innovations can be made and, more crucially, be maintained locally, allowing cost-effective and productive usage of all the primary irrigation tools.
One of the tools that helps them to manage their water resources is the wetting front detector. So this tool is an indicator of when to stop the irrigation, when the yellow flag within this wetting front detector pops up. And we also installed some instruments that measures the soil moisture status of their plot, so that when to irrigate and when to stop the irrigation. Another tool that we distribute to the farmers is an exciting tool, the Berkan plow tool, which tries to break the natural hard pan. So breaking the hard pan improves the infiltration of the water vertically, so that more water will be available in the groundwater, and also more water will be available within the soil moisture pores.
The solar pump system has really changed the way I'm able to work on the farm. I used to have a pulley system before, and then had to make a choice between a generator and a solar panel. I chose a solar panel because it's so much more cost effective. It really has changed the way we are able to source and save water, and it's much easier and cheaper for ourselves to do this than before. We do have to generally wait for a clear sunny day for it to work at a full capacity, and I do think that I'll need a water tanker to store water reserves. But overall, I can water all my plants efficiently at the correct time of day or night, and this helps me to improve the quality and amount of my crop yields.
Increasing yields and efficiency are just a few objectives of the ILSSI project. Other components include regular assessments, field studies, analysis, and critically, household surveys targeting women farmers and determining the real impact of the intervention on all family members.
The fact that the hole has a cover is good, as it prevents the children from falling in and getting injured. Secondly, we get clean water, not like before, because dust and leaves do not enter it. Plus, we don't have to go long distances to get water. When we are making injera, we can still go out and fetch water because its location is nearby. Our plants get enough water as well. The hole has a lot of depth, and it is sometimes tiresome to pull out the water, but we take breaks in between and are still happy because clean water is vital to us.
All farmers receive support and training in the field, and also give feedback to determine which interventions prove most fruitful.
After the end of the project, we will do the survey to see whether there is an impact on increasing the production of a vegetable, saving the water, saving their labor time, and whether it generates income compared to the other households where there is no any such interventions.
I have been part of this project for the last 3 years, and during this time, the new instruments have definitely helped us. The tanker I have has its own structure. I climb up there and pour the water inside after getting it from the pulley. Once it's all dripped, I then use a measuring tool called TDR to assess how much of water there is. Comparing this method with previous methods we used, this one by far has much better results and allows us to correctly use and save the water we need for all our crops, even during the drier seasons.
The goal of the Innovation Lab is to define the most effective irrigation systems and practices, from water lifting, distribution and monitoring methods that will enhance the lives of smallholder farmers like Germa Yohane and his family in Ethiopia, and present the opportunity to transform the lives of the next generation of farmers.